In this video, I will be presenting the median search algorithm. So far, we have seen the linear search, binary search, and jump search algorithms. Median search, unlike linear search, binary search, and the jump search, in median search, we are mainly identifying the median of a given list of elements. Like linear search technique, the elements need not be in sorted order in the case of median search. In general, median will be calculated like if you have a list of elements, then those list of elements will be sorted in the ascending order, and you take the middle value of the sorted list, then it will become the median of that list. But sorting the entire list and going through and identifying the middle, obviously it will be almost equal to the searching the middle value is almost equal to the sorting. So thereby the median search is a technique without sorting the elements itself. We can identify what is the first median, second median, third median, or fourth median in the unsorted list. That means whatever the median you want. The first median means in a sorted list, whatever the first one is there, that is the first median. Second median, third median, like that. Whatever is the second highest one is the second median. So like that, we'll identify the medians without sorting the list. That is what the specialty of this median search. Now we'll see how this particular median search will work. Let us define the medians of n numerical values by the median of a list of n values is founded by sorting the input array in increasing order, just now as I told, and taking the middle value. This entire procedure will take the time complexity as order of n log n time in the average or best case. Example, consider the input values as 19, 10, 84, 11, and 23. Now, if you arrange in the ascending order, it will be like 10, 11, 19, 23, and 84. Now, what is the middle element in the sorted list? 19. So, median is 19. The first, according to the first definition, it is easy to grasp, but is given through an algorithm. Sort the array, take the central value, which is not the best way to define such a concept because we are supposed to perform entire sorting. Okay, it's just like in binary search and jump search, we'll perform the sorting. Then on the sorted list, we'll go for the binary search, application of the binary search or jump search. But here, without doing that, how can we do? How can we identify the first largest element, first smallest element, second smallest element, third smallest element, like that. So finding the kth element in the array also requires to store the array first, then select the kth element. This also takes the running time more than the linear time. However, it is moderately low compared to the previous case. We want to find some algorithm that finds the median element in a linear time. The latter definition is more interesting since it leaves us without having the choice of leaves out the choice of the algorithm. That means in what way you will do is left to you. So that is the reason here a simple technique is used that I will explain in the next slide. A simple technique is used to identify the median. The You can give the median, that is fourth median I want or third median I want. Then we are going to use the subset construction method. Via the subset construction method, we can identify this median search within the low time complexity. Here is the median search algorithm. Using this algorithm, you can find out median as well as the kth smallest element in the given array of the array is of unsorted array. Let S is the list of numerical values and K is the rank of the kth smallest element in S. Now, the procedure will go like this. The procedure select of K comma S. That means I want to find out, say for example, fourth smallest element or median fourth median in the list, that is the numerical values that I have supplied, that is S. If S is equal to 1, that means if there exists only one element in the list, then return the single list element, that is S. Else, choose an element A randomly from S. That means if the S is consisting of 10 elements, choose a random element, one element randomly. Either it may be sixth element, seventh element, or fourth element, or whatever. Let a S1, S2, S3 be the sequences of elements in S respectively. Okay. Now this S will be divided into three subsets: S1, S2, S3. The elements which are less than A will be placed in S1. The randomly chosen element will be there in the S2. The elements that are greater than the randomly chosen element will be placed in S3. Okay, is it clear? The element, you are going to choose a random element randomly from the list S. Now, what you are supposed to do is you are supposed to construct subsets S1, S2, S3, in which the elements which are less than this random element will be placed in S1. Whatever the random element that you have chosen will be placed in S2. The elements that are greater than the random element will be placed in S3. So this let S1, S2, S3 be the sequences of elements S respectively less, comma, equal to and greater than A. Okay. If S1 is greater than or equal to K. Okay. If S1 is equal to greater than or equal to K. Here this symbol represents the length of S1. Okay. The length of S1 is greater than or equal to the element that the minimum element that what you are going to choose, then return select of K comma S1. Down, that means whatever the median element that you want, that median element, comma, you are supposed to recursively apply this S1 subset here. Else, if S1 plus S2, that is length of S1 and length of S2 is greater than K, then return the K. This is what the value. Okay. Else, return select of K minus length of S1 minus length of S2, that value to be placed here, comma, you are supposed to apply now recursively this select procedure on S3. Okay, on this S3. So this is the way you are supposed to perform the median search to identify the kth smallest element or kth median in the list of unsorted elements. So here very simple three conditions. The first one is you are supposed to take a random number from the unsorted list and create three subsets. In first subset, the elements which are less than the randomly chosen element will be placed. The randomly chosen element will be placed in S2, and the elements that are greater than the randomly chosen element will be placed in S3. Now these three will be checked. If the subset S1 length is greater than the median that what we are going to search, then return this particular recursively select of K comma. Now you are supposed to apply the median search on S1, that is subset 1. Else if length of S1 plus S2 is greater than or equal to K, then return whatever the randomly chosen element is the element. Return select of K minus S1 minus S2. Then that is you are supposed to recursively apply this median search on the this third subset, that is S3. By what you are supposed to do, you are supposed to deduct K minus length of S1 minus length of S2. Then whatever is the resultant value you will get here, you are supposed to find that particular median on this particular third subset. So this is what the median search algorithm. Here median means the length, that is the whether it is the what type of element is it. Is a case smallest element, that is first smallest element or second smallest element or third smallest element. This is what the difference that you are supposed to identify or that you are supposed to recognize between the linear search, binary search, and jump search. In linear, binary, and jump search, you are going to particularly give the element and you are asked to go for the search. But here, element is not asked. Here, it is asked as the fourth smallest element or sixth smallest element, not exact element here. Here, the ranking of the element, whether it is second smallest or third smallest or fourth smallest or sixth smallest in the given list of elements. That is what the difference between the linear, binary, and jump search and median search. Okay. Next, we will move on to a simple example. Here, the list of elements 7, 10, 4, 3, 20, 15, 8, 12, 6. These are the elements that are in the unsorted manner. Now, I want to find the fourth median. So, obviously, the fourth median is 7 because if you arrange in the sorted order 3, 4, 6, 7, then 10, sorry, 3, 4, 6, 7, 8, 10, 12, 15, 20. This is the sorted order. So in this 3, 4, 6, 7, which is the fourth one, that is what the fourth median. So actually 7 is the fourth median in the entire list. So here we are asking for the fourth median. We are not asking about the element 7. Okay, this is what the difference between the previous search algorithms that what we have discussed and this search algorithm. Find the k is equal to fourth median. Now randomly choose an element a is okay, randomly choose an element from this particular list. Let's say for example a is equal to 10. Okay, you may choose 15, 8 also, that is okay. You choose randomly, you use a random function in while writing the program and choose a random number from this particular list. Let's say in the random process we got the element a is equal to 10. Now divide this list, unsorted list, whatever the list is there, S, we call it as S, into three subsets. First one is S1 is equal to the elements that are less than the randomly chosen element will be placed here in S1. The randomly chosen element will be placed in S2. The elements that are greater than randomly chosen element will be placed in S3. Okay. Now A is equal to 10. The elements that are less than 10. What are the elements less than 10? 7, 4, 3, 8, and 6 that were placed in S1. Next, S2 is equal to the randomly chosen element. Elements that are greater than the randomly chosen element, that is 20, 15, and 12, are placed in subset S3. Now, look for the condition. If length of S1 is greater than k, then return this. Now, length of S1. What is the length of S1? 1, 2, 3, 4, 5. Okay. Now, 5. 5 is greater than the fourth median, 4. The k value, what we have asked for. 5 is greater than 4. So, that is the reason what you are supposed to do. You are supposed to place k as 4 only, but you are supposed to apply the same thing on S1. Okay. Now, you are supposed to perform the fourth median search on S1. Now check in the array S1 is equal to 7, 4, 3, 8, 6. Repeat the same process, choose a random number from this. Let's say for example, in the random number identification, random number picking, we got the random number as 3. Now what you are supposed to do? You are supposed to perform subset construction on S1. Now divide array S1 into 3 parts. Say for example, S11, S12, S13. Elements that are less than S1, sorry, elements that are less than the randomly chosen element will be placed in S11. Elements that are greater than randomly chosen element will be placed in S13. So in this list there is no element which is less than 3. So S1 subset is empty. The randomly chosen element will be placed in S12, that is 3. The elements that are greater than randomly chosen element is in S13, that is 7, 4, 8, 6. Now apply this condition, that is S1 plus S2 is greater than K or not. Check it. S1, S11 plus S12. Length of S11 is 0. Length of S12 is 1. 0 plus 1 is 1 only. 1 is not greater than 4. So the second condition failed. Next, length of S1 is greater than K or not. Length of S1 is 0. So two conditions were failed. These two conditions were failed. So only the leftover condition is this one. Return select of K minus length of S1 minus length of S2. Now here first and second conditions were failed. So the third condition is true. So then call recursively select of K minus, what is the K? 4. 4 minus length of S1 0 minus length of S12, which is 1. 4 minus 1 is 3. So 3, and you are supposed to place it as a S13. That means this particular array should be this particular sub array should be placed here. Now repeatedly again select a random number from the subset S13. Now here K is equal to 3. Now repeatedly select a random number from this subset here. Assume that the random number that we have chosen is 7. Now divide S13 into 3 parts like S131, S132, S133, in which elements less than 7 are placed in S131. The randomly chosen element will be there in S132. Elements that are greater than randomly chosen element will be placed in S133. Now check whether the condition length of S131 is greater than K or not. So the first condition will fail. Now length of S131 plus length of S132 is equal to K or not. Obviously the condition 2 is true. So that is the reason return the value A. So returns the median A is equal to 7. Now the fourth median in the list, is 7. That is what the thing that was returned. This is the way how the median search will work. Now we'll see programming part. I am adding this median search algorithm in the searching.c file itself. Median search. So let will define the median search algorithm. Obviously in the median search we need to have median underscore search of we need to have this array and the starting value lower index int L and the higher index R and the kth median that we are supposed to identify. Okay. Now we need to calculate how many elements are there in this. That is int in index is equal to R R minus L plus 1. That many number of elements are there. Next is we need to choose a number randomly. Int index is equal to, since we have placed rand, let will include math.h. Anyhow, we have included math.h for some other purpose. Next, to iterate the loop, we will take a index variable I, and to keep track of the size of the first subset, second subset, and third subset. There are 3 subsets we are going to form. To keep track of the size of these subsets, we'll keep some variables like j, which is initialized to 0, j is equal to 0, and m is equal to 0, and n is equal to 0. So 3 subsets and 3 lengths, so we are supposed to find out. Next is once we'll make it, obviously we need to keep track of the subsets. So what we'll do is we'll create some temporary arrays. Okay, we'll create some temporary arrays int s1 s1 of 10. This is a temporary array s1 of 10 is equal to nothing. Okay, s2 of 12, s2 of 10, sorry, and s3 of 10. So these are the 3 subsets. So 10 elements, maximum of 10 elements. Okay, we can increase it also. Anyhow, we'll take for example some small number of elements and we'll test it. So this is over. Now what we are supposed to do, we need to create the subsets. Okay, the creating of the subsets like this: for I is equal to 0, I less than r is the maximum index. So the till the maximum index we are supposed to go for I plus plus. Now we need to check whether the uh, array of I is less than this randomly chosen index related element or not. So if a of I is less than a of index, then we'll place it in the first subset. Otherwise, we'll place it in the that is, if it is greater than, then we'll place it in the third subset. Okay. So that is if a of I is less than a of index. Okay, this is the random index that what we have chosen. Then s1 of j. So initially j is equal to 0. S1 of j is equal to a of I. Then j plus plus. We need to increment the j. Anyhow, I index is incrementing in the for loop. Else if a of I is equal to a of index, then s2 of m is equal to a of I. Because whatever the randomly chosen element is there, that will be placed in second subset. Then in third subset, what we are supposed to do? We are supposed to place. Sometimes there may be duplicate elements in the array. So the reason, if the duplicate element is chosen as the median element to search, sometimes it is better to go for incrementing of m plus plus like this. So if not these two conditions, obviously the element will be greater than the elements that are greater than the randomly chosen element will be evolved, and those will be placed in the third subset. Then S3 of n is equal to a of I and n plus plus. So with this, our separating of the arrays, separating of the elements into, or dividing the elements into subsets are over. Now go to the recall these particular conditions. If the size of or the length of the first subset is greater than or equal to the index that what we have, median value that what we have chosen, that is k, then we need to perform the median search on the first subset. if length of the first subset and the length of the second subset is greater than the median value chosen, then return the particular random value. Else, we need to go for median search of k minus length of the first subset minus length of the second subset, comma third subset. Let us implement this. If length of okay length of subset 1, length of subset 1 means j is greater than or equal to the median k, then we need to go for median search of a comma the not a here s1 comma 0 comma j, okay, and k. Else, if j plus m is greater than or equal to k, j plus m means length of subset 1 plus the length of subset 2. So j plus m is greater than or equal to k, then return a of index. Else, median search of s3 s3 comma 0 comma here the length of s3 is n comma k minus j minus m, that is length of s1 minus length of s2. So this is the recursive way of calling the median search on the subset 1 and subset 3 based upon the condition. Or we may also say k minus take minus comma j plus m. This is also fine. You can also say. Now we'll go for implementing the main method. So we don't want quick sort. We don't want this one. So printf backslash n. No, median search on A. Here already array A is declared. In this, let will calculate the fourth median. If you arrange in the sorted order, 3 is the smallest element, 3, 4, and next smallest element is 8 and 9. So fourth median is 9. That will see 0, a comma 0 comma a comma 0 comma r value, that is size comma. I want fourth median as k. K is equal to, so searching for k is equal to 4 median. So this is the function call that I have made, that will see the output. That will run the code, not giving anything. That will cross check this. I hope it is instead of multiplication, it should be division. And I have replaced it. Since here I have placed size minus 1, I have replaced j to j minus 1 and n to n minus 1. Because modulo operation will give the index number within that range. Here the random number is generated maybe going more than 100, I think so. For that reason. So I'm running this, and first index is 13974 it was coming. So that means it is working fine. So what I'll do is I will comment this, and okay, to return a of index, it must be of integer type, right? So that will make it as integer type. Return type is integer. Accordingly, we'll change int mid is equal to one printf the kth percentile D median is percentile D, comma k comma median. Here another modification I am making is I less than or equal to r, because we have given the size as size -1. That's the reason it is better to place I. Obviously, it is supposed to place I less than or equal to r. Here one more small change. Here this is equal to a of I is equal to a of index. So in the main method, I have made it as k is equal to 4, which is for the fourth median to search, and median is equal to median underscore search of a comma 0 comma size -1 4, and zeroth median is percentile D. Now we'll run the code and we'll see. Yeah, the fourth median is 8. That is what we have expected. 8 is the fourth median. That's what we got. So this is the end of the median search algorithm.